Okay, the last section is 11.3. So I just taught you vectors. That was chapter 8 of trigonometry. Okay, now I have to review polar equations, which was trigonometry. So again, the first thing I'm going to do is I'm going to spend a lot of time just reviewing polar coordinates. And then once I review polar coordinates, I'm going to show you how that relates to calculus and finding the derivative and the integration of polar coordinates. So here's the review for trigonometry. When you do polar coordinates, do you guys remember in trigonometry we use the bullseye? The points are called r theta. So for example, if I wanted to graph 2, 30 degrees, I would go out 2 circles, and this is about 30 degrees. So this is 2, 30 degrees. Let's say we want to do, okay, this is a positive r, and this is a positive theta. This is a positive r and a negative theta. They might do this. They might give you a negative r. This is a positive theta. This is a negative r. This is a negative theta. So, for example, I just showed you how to graph 2, 30. I'm going to show you how to graph 2, negative 30, which will be the red dot. So I go out 2 circles, but instead of going up, I'm going to go down a negative 30, which is about right there. Now I'm going to show you how to graph a negative r and a positive 30. So let's do a negative to 90 degrees. So if I wanted to graph, I'm going to do this one in green. Let's say I want to graph a negative 2, 90. A negative 2, I need to go out to the left, and then I need to go down 90. This is about a negative 290. I went out here first because it was a negative r, and I went down. I went down because of my positive theta. So in 9.1 in trigonometry, the first thing you did was learn how to graph points. After you did that, you learned how to go back and forth from polar to Cartesian. Okay, what's a Cartesian? Basically, if I told you Cartesian is x comma y. So basically, if I told you to graph 2 comma, let's say I told you to graph 2 comma 2 squared root of 2, I go over 2. Let's just make it 2 comma 2 instead. I go over 2 and up 2. If I put this graph right here on top of that, they're very, very similar in the same spot. So how did we used to graph? We used to graph in Cartesian form, and the top was in polar form. So you need to know these formulas, and these formulas are important. X equals r cosine of theta, and y equals r sine of theta. Okay, this is really important because the x and the y are in Cartesian form, and this is in polar form. So if you want to go back and forth, you need to know these formulas, and this is really important, and I'm going to do some examples. Another thing you need to know is that x squared plus y squared equals r squared, and you need to know that the tangent inverse of whatever the theta is, y divided by x. And you had all this, but you haven't had this for 2 years. So I'm just going to give you an example. I showed you how to do points. Now we're going to do equations. So I'm just going to give you some examples, and hopefully. Okay, so basically if I wanted to plot a point, it's r comma theta in polar. Cartesian, it's x comma y. So just to give you a heads up. Polar form, r cosine of theta equals 2. So how do you put that into Cartesian? If you look up here, r cosine of theta is the same thing as x, so all I'm going to say is x equals 2. Okay, just to give you a little bit of a heads up, if I wanted to graph this, Isn't this a vertical line at x equals 2? So if I wanted to graph this, this is also a vertical line. How do I graph it? I'd like r equal 2 cosine of 30, then r equals 3 cosine of 40 or whatever, and I would make myself my vertical line. Another one is r squared cosine of theta sine of theta equals 4. So what does that look like in Cartesian? Well, there's two r's sitting here. Can't you break this up into r cosine of theta and r sine of theta equals 4? So I just took the r and I gave them each one. And this stands for x and this stands for y. So isn't x times y equal 4? Okay, another one. We'll do a couple more. R squared cosine squared theta minus r squared sine of theta equals 1. Again, I can break this up. This is really r cosine of theta, r cosine of theta, minus r sine, that was supposed to be a square too, and r sine of theta equals 1. So basically, what does this look like in Cartesian? You really have x squared minus y squared equals 1. And the last one, if you see r equals 1 plus 2r cosine of theta, all I'm going to do is change my r. Do you remember that my r stood for, I'm going to switch this to x, and all I'm going to do is take the square root. If r is equal to, r squared is equal to x squared plus y squared, which is going to equal the square root of x squared plus y squared equals 1 plus 2x. And then all I'm going to do is square both sides. I guess I'm doing this. It's really supposed to be over here, sorry. So then I'm going to square both sides, which is x squared plus y squared. And 1 plus 2x times 1 plus 2x, if I square that, is 1 plus 4x plus 4x squared. And then I'm just going to bring everything over to one side. 0 equals 1 plus 4x plus 3x squared minus y squared. Okay, so I'm going to just give you two examples. How do we convert from Cartesian to polar? X squared plus y minus 3 squared equals 9. So, just to give you a heads up, if I wanted to graph this, I'm hoping you know that that's an equation of a circle at x equals 0 and y equals 3. So that's the center of your circle, is that 0, comma 3. You learned this in trig. You also learned it in college algebra. The radius of the circle is the square root of 9, which is 3. So you're going to go out 3, up 3, left 3, right 3. This is what the picture looks like in Cartesian. Now I want to show you how to change this into polar. So I'm just going to go x squared plus, if I square this, I'm going to get y squared minus 6y plus 9 equals 9, which makes x squared plus y squared minus 6y equals 0, because the 9's cancel out. Okay, x squared plus y squared, I'm just going to go back to that, right here. X squared plus y squared equals what? Equals r squared. So all I'm going to do is substitute r squared here, minus 6. And what do I change y to? I'm going to go back to my formula. I'm going to change y to this, r sine of theta. So that's equals 0. And I'm just going to leave it like that. Okay, the next one, I'm going to go the other direction. I'm going to convert from polar to Cartesian. So they give you r squared equals 4r cosine of theta. I'm going to change r squared to x squared plus y squared. I'm going to change this to an x. I'm going to bring the 4x over. Okay. Now, I need to put this into more of a circle formula. This is where it gets kind of confusing. I'm going to complete the square, if you remember this. There's a lot to remember from other sections. Now in Calculus BC, you're going to see how all of this ties in and why we needed to learn how to do polar coordinates. You didn't understand why we needed to do chapter 9 2 years ago, but now this leads into it. So this is going to be x squared minus 4x plus something plus y squared equals 0. So I'm just going to complete the square with my x's. I'm going to take half my b value, remember doing this? Half of a negative 4 is a negative 2, and then I'm going to square that, and whatever I do to that side, I have to do to that side. If I did it right, I made a complete square. That's really x minus 2 to the second plus y squared equals 4. If I wanted to graph this now, this is a circle formula. I'm going to go out 2, nowhere on the y-axis, so that's the center of my circle. And since this is a 4, you're going to go up 2, right 2, down 2, and this is what it would look like. If you don't remember, I'll give you the equation of a circle. I'll put it over here. X minus h squared plus y minus k squared equals r squared. H and k stood for the center of the circle, and the r stands for the radius. If you remember this, I hope you do. Okay, so I just showed you how to go from polar, but now I need to review all the polar curves that we learned. And I'm hoping you remember this. I need you to open up your books to page 562 to 564, and I'm going to go over all those curves with you that we learned in chapter 9 2 years ago. Hopefully you remember this. You know what I'm going to do is I'm going to take out my trig book, and I'm just going to kind of give you the formulas really quick. And hopefully you remember these. Okay, here they are. There was a chart in the pre-calculus book. The first one made a rose. And here's the equation. R equals A cosine of n theta. And R equals A sine of n theta. So what you made was a rose. And a rose has petals. It has 4 petals. It has 3 petals. Whoops. It has 6 petals. They're supposed to be nice, like they look like a rose. The next one was a lemniscate. The formula is r squared equals a squared cosine of n theta, and r squared equals a squared sine of not n theta, 2 theta. This looks like the infinity sign. Okay, and I'm going to try to make these a little bit nicer up here. I tried. So, okay, the next one was a Lima sun. And the formula was R equals A plus B cosine of theta, and R equals A plus B sine of theta. And a Lima sun has, I'll just give you, I have to start again. It looks like a fat heart with a loop in it. So it looks something like that. Okay, the next one is a cardioid. Okay. And this is r equals a plus a cosine of theta, and r equals a plus a sine of theta. This one looks like just the heart. And the last one is the Spiral of Archimedes, which is r equals a theta. So, back in the old days, I would give you a formula, and let's say I gave you r equals 2 sine of 3 theta. And all you did was you made a theta and an r chart. And you started out with 0, and this is 30, this is 60, this is 90, this is 120, 150. And what you did was, when sine is 0, you get 0. When sine is 90, because 30 times 3 is 90, the sine of 90, and you plotted points, the sine of 90 is 1, you get 2. Okay, but there's another way you can do this. So, instead of doing it the long way, like we did back in the olden days, I want you to take your calculators out, and I need you to go to your mode, and I need you to go to your mode, and I need to change it to POL, which stands for polar. Hit enter. Now, instead of function or parametric, we're in polar form, which is the fourth one down. I need you to hit your y equals button on your calculator. And as you can see, instead of y's or x's and y's, now we have r. And we're going to put r equals, and we're going to put that into your calculator, 2 sine of 3 theta. So I'm going to give you some time. I'm going to plug it into. And you're going to hit your variable button. When you hit your variable button, it's not an x, it's a theta. So r equals 2 sine of theta, and when you graph it, it should make yourself a rose. Okay, it didn't, because I was in degrees instead of radians. So I'm sorry, I have to, whenever you work in sine or cosine, remember your calculator needs to be in radians. So I start it one more time. Now I'm going to hit graph. It's very small, but if you want to blow it up, you can just go to zoom, and I'm going to put zoom fit to see what it looks like. And this is what it looks like. Zoom fit looks like that. So you're going to be using your calculator. You're going to put it into polar form, and you're going to work with r equals 2 sine of 3 theta. Remember, if you sine or cosine, you need to work in radians. So instead of doing it the long way like we did in trigonometry, you can just use your calculator to make the rows. What I would do, if maybe you want to make all of them, maybe you want to do a couple more, maybe I'll give you a couple more to do. Let's see, I will give you r equals 3 theta. This should make a Spiral of Archimedes. Try that one on your calculator. I'm getting these out of the trig book. I'm going to give you a lemma sketch, which is r squared equals 4 cosine 2 theta. This should make a lemma sketch. I'm going to give you one more. I'd like to give you a loop-de-loop one if I can. Yes, I'm going to give you one more. I'm going to give you r equals 3 minus 5 cosine of theta, which is, I don't know these that well, this one is the Lima sum. Okay, now, since I just reviewed with you, now I'm going to work with calculus. So here we go. We are going to figure out the slope of a polar. How do you find the slope of a polar curve? It's dy over dx. So it's just dy theta, d theta, over dx d theta. So here's an example. Find the slope of the rows r equals 2 sine of 3 theta at a point theta equals pi over 6, which is the same thing as 30 degrees. You can graph this on your calculator, and it ends up being that picture that I think we just did. I know it's not the best picture. But all you have to do is find dy dx. And let's see. So all you're going to do now is remember that x equals r cosine of theta and y equals r sine of theta. So now you're just going to use the product rule to solve and find the derivative or the slope of the line. So in place of x, let's put it over here, x equals 2 sine, whoops, we're going to put it back into Cartesian form. So r is given to you, which is this. So in place of r here and r here, we're going to substitute this. So r equals 2 sine of 3 theta with your cosine of theta at the end. Y equals 2 sine of 3 theta with the sine of theta at the end. Okay, so now I'm going to find the derivative dy dx over, start again, dy d theta divided by dx d theta. So in order to find the derivative of this and this, I need to use the product rule. uv prime plus du prime. Okay, so I need to do uv prime plus du prime. So I'm going to put the 2 with the cosine of theta, that's my u, and this is my v. So I'm going to take the derivative of x, which is 2 times the derivative, 2 cosine of theta, which is my u, times the derivative of sine 3 theta. Put the 3 out in front, and the derivative of sine is cosine, plus, so that was uv prime, now I'm going to do vu prime. So I need to keep the sine of 3 theta and take the derivative of 2 cosine of theta, which is a negative 2 sine of theta. And I should have put the negative 2 in front, but I didn't. Same thing with this one. I'm going to make this 1, and then I'm going to put these 2 together to make the v. So I'm going to do 2 sine of theta times the derivative of sine, which is the same thing, 3 cosine 3 theta, plus, great, I'm running out of room, sine 3 theta times the derivative of 2 sine of theta, which is just 2 cosine of theta. Okay, so then all I have to do is put my pi over 6 in there. So I need to make a picture of pi over 6, which is 30. 1, 2 square root of 3. And 0, 1, which is 90, and I'll tell you why I did that in a second. Again, this section is very time consuming. I have to teach you the polar part first, and now I'm finally teaching you the calculus part. So I need to put pi over 6 in here. It's not going to be pi over 6 here. This is going to be 30 degrees. But when I put 30 there, 30 times 30 is 90. So what is the sine, what is the cosine of 90 degrees? The cosine of 90 is 0. So basically all of this turns out to just be a 0. But then this part, the sine of 90 is 1 times 2 times the cosine of 30, and the cosine of 30 is the square root of 3 over 2. Do the same thing with the bottom. This whole part is going to end up being a 0, so I don't even really need to do it. But the sine of 90 is 1 again. And then you're going to do a negative 2 times the sine of this picture, and the sine of this picture is 1/2. So, what is the derivative finally? The 2's cancel out, and you're left with the square root of 3. The 2's cancel out, you're left with a negative 1. So what is the slope? The slope is a negative square root of 3. But I'm going to find the equation. So I'm going to do this y minus y equals mx minus x that we've been doing forever. In place of m, I'm going to put a negative square root of 3. And then I'm going to put in place of my x and my y. As you can see, theta is equal to pi over 6. That's not the answer for my x and my y. The answer for my x and y is up here. And here is, right here, the answer to my x and y is hiding right here. My x is equal to 2 sine of 3 theta cosine theta. So in place of my thetas, I need to put pi over 6. And just to hurry this up, when you put pi over 6 in here, you're going to get the square root of 3. When you put pi over 6 in here, you're going to get 1. So, in place of my y, I'm going to put 1. In place of here, I'm going to put the square root of 3. No, do not simplify it. Leave it like that. Okay, the next part. I'm going to give you all of these formulas. Area of a polar curve. You're going to integrate from alpha to beta, 1/2 r squared d theta. That's the area of a polar curve. But how do you find the area between two polar curves? You're going to integrate alpha to beta, 1/2 r squared 2 d theta minus top minus bottom like you did before, which is equal to alpha beta 1/2 r2 squared minus r1 squared. So I'm just going to give you 2 examples, and that's about it. The old book used to teach you the length of a curve. I'm just going to give it to you. I don't know if it's going to be on the A, B, C test, but I'm just going to give you the length of a curve. The length of a curve is from alpha to beta, the square root, just like you know how to find the length of a curve, r squared plus dr d theta squared. I don't know, I don't think there's any examples that do this in this book, but just to keep in mind that the length of the curve. What I'm going to show you are the next 2 examples are these 2. So I'm going to show you how to find the area underneath a polar curve. Okay, here we go. Find the area of r equals 2 parentheses 1 plus cosine of theta. And I'm just going to show you the picture of it. So what you would do is you go under your calculator, change your calculator to polar, make sure it's in radians, put that into your calculator, and this is what it looks like. So basically, we're going to integrate from 0 to 2 pi. How did we get that? This is 0, and out here is 2 pi. So you can figure out, you can go to intersection, and you can figure out where this intersects. Okay, once you do that, you're just going to use the formula. You're going to take 1/2 r squared d theta. So I'm just going to do the distributive property and make it 2 plus 2 cosine of theta squared theta. So if you use your calculator, you're going to end up getting 6 pi, which ends up being 18.850. If you don't use your calculator, I'm going to show you the long way just in case. So, the first thing I'm going to do is we have to simplify all this. So I'm going to leave it as 1/2. What happens if you take this and you square it? You're going to get 4 plus 4 cosine thetas plus 4 cosine squared theta d theta. And then I'm just going to take 1/2 of all that. So you're going to get 0 to 2 pi, 2 plus 2 cosine of theta plus 2 cosine squared theta d theta. Okay, at the beginning of the year, I gave you a formula sheet. I gave you a trig formula sheet, and I gave you the AP Calculus BC. So, I'm just going to show you this right here. I'm just going to show you how they simplified this. I'm going to leave cosine squared theta minus 1. 2 of those is equal to cosine 2 theta. This was a double angle formula. You can locate this on your formula sheet in trigonometry on the back side in the top right hand corner. You can find this formula. And all they did was they got cosine squared alone. They added both sides, 1, and they divided by 2. So they got cosine squared theta alone. And what they did was they substituted in place of that this. So they integrated from 0 to 2 pi, 2 plus 2 cosine theta, plus, they left the 2 there, but in place of that circle, they put cosine 2 theta plus 1 over 2 d theta, and the 2's cancel out. So now, this 1 and this 2 can go together to make 3 plus 2 cosine theta plus cosine 2 theta, all of this still d theta, which makes, when you integrate 3, you get 3 theta. When you integrate this, you get, did I do that wrong? Did I forget my 4? I forgot my 4. When you, how did I go from there to, yes, I'm sorry. How did I go? Oh, I took 1/2 of that, which is 2. And then, when I integrate that, it's going to be 2 sine of theta. And then you need to use U substitution, and you're going to get sine of 2 theta divided by 2 from 0 to 2 pi. The next one is, you can follow along with me on page 561. And I'm just going to show you example number 8, which is the area between 2 curves. So, they give you r equals 1 minus cosine of theta. And they give you r equals 1. So you graph both of these on your graphing calculator, and there's a picture of them already, but I'll just give it to you. This is the circle, and the other one is this one. And basically you're going to find the area right here. So the area between 2 curves is this. This is a lot of notes. That's why BC is way harder. Right here. The area between 2 curves is right here. You're going to integrate alpha to beta, r squared theta, and 1/2 of that. So basically, we're going to go over here, and we are going to integrate from a negative pi over 2 to a positive pi over 2. This is pi over 2, and this is a negative pi over 2. And we're going to do 1/2, and we're going to do R2 first, and the R2 is R equals 1. So we're going to take 1 and square it, minus 1 minus cosine theta and square it, d theta. Where did I get this from? Again, I got it from here. You take each one and you're squaring them and subtracting it. Instead, I wrote it like this. So I took the first one, my 1, and I squared it, and then I took R1 and I squared it. And then they simplified it. You're going from a negative pi over 2 to pi over 2. 1/2, 1 squared is 1. And then you got to be careful because of this wonderful minus sign. You have to square that. You're going to get 1 minus 2 cosine theta plus cosine squared theta, d theta. You're going to integrate from a negative pi over 2, pi over 2. 1 minus 1 cancels out. So you're really going to be left with 1/2 of a negative 2, which is a negative cosine of theta. And you're just going to do this again. They simplified this. I just gave you that formula from trig. 1 minus cosine squared theta equals cosine 2 theta. And I'm just kind of hurrying this up. You're going to end up getting there's 2 of them because of I'm integrating from there to there because there's 2 of them. So there's a 2 and there's these cancel out. So you're left with negative 2 cosine theta. But instead of doing all this, just use the first one and you are going to get 1.215. Just use your calculator to come up with this. I'm hoping on the APBC test, they'll just let you use your calculator. So I'm just going to read through it with you. Find the area of the region that lies inside the circle R equals 1 and outside the cardioid R equals 1 minus cosine theta. So, using the formula for the area between the two, you see that you have 2, and I'm going to only integrate from 0 to pi over 2. That's where the 2 came from. I integrated from a negative pi over 2 to pi over 2. You don't need the 2 in there because they integrated from 0 to pi over 2, so I would have just left it like this and used my calculator and got 1.215. So that's where the 2 came in. They only integrated from 0 to pi over 2. I integrated from a negative pi over 2 to a positive pi over 2. So, this again is very time consuming. Take your time. You'll need at least 3 to 4 days to do polar equations.